Hello everyone and welcome to an algebra tutorial video. We're learning about properties of exponents in this series. Specifically, the one right before this, we actually defined what a negative exponent was and saw that when you have a negative exponent, it implies repeated division. But in this one, I wanted to go over some examples of applying exponents, and specifically negative exponents, into simplifying and rewriting algebraic expressions. So we got 4 different problems we're going to go through. We're going to look at each one of these and see how we can rewrite them using our understanding of negative exponents as well as all of our other exponent properties, and then rewrite them in a simpler way. Now, in general, for your math class, to simplify means you rewrite it with no negative exponents. So I'm going to write that out here. Simplify with no negative exponents. So I want to rewrite the whole expression, but make sure that there are only positive exponents. All right, let's start with this first one. 3x and the x is to the negative 5th power. Well, if I use my negative exponent, I know anything to a negative exponent can be rewritten as a division problem. 1 divided by b to the positive n power. So that negative just implies division. So I'm going to apply that with this first problem. The 3 is fine. I'm not doing anything to the 3, so I'm going to keep the 3 where it is. It's 3 times. But now the x is to the negative 5 power. So I need to rewrite that as, well, that's 1 divided by 5x's. So it's 3 times 1 over x to the 5th. Well, I can rewrite that. I can combine them both together. That just means it's 3 divided by x to the 5th power. And that would be simplified. Now let's take a look at another one. I now have a fraction. I got a divided by 4, but it's all to the negative 2 power. Well, previously we've looked at with fractions that negative 2, or the exponent, applies to both the numerator and the denominator. So I can rewrite this as a to the negative 2 power divided by 4 to the negative 2 power. Well, now here's where things get interesting. And I'm going to tag on a little extra. So b to the negative m power means I'm dividing by b to the m, right? But what if I have a negative exponent that I'm already dividing by? So 1 over b to the negative m, now my negative's in the denominator. Well, now it's like the opposite of the opposite. It turns back into multiplying with the positive. So do you catch the difference? If I have b to the negative m, that turns into division. But if I'm dividing by b to the negative m, the opposite of double division then turns it back into multiplication. So in this case, I'm going to write them out separately. The a squared, the a to the negative 2 on top, ends up turning into 1 divided by a to the positive 2, just like this one up here. But I have, on the bottom, I have 4 to the negative 2 power. So that's considered 1 divided by 4 to the negative 2 power. And that can be rewritten as 4 to the positive 2 power on the top. Now you can put divided by 1, but I don't really need it. Now let's combine these two, my a variable and the 4, and we can see that it should be 4 squared. Whoops, I don't like that color. And this one, 4 squared divided by a squared. This 4 with the negative 2 on the bottom went up to the top and turned into positive. But the a to the negative 2 on top turned into division on the bottom. That's where we have the a squared on the bottom. And I can simplify that one more step and get 16 over a squared. All right, did you follow all that along? In some senses, a negative exponent is as simple as moving above or below the fraction bar to turn it into a positive exponent. But I'm really trying to conceptually make sense of why we can do that or how it works. And we're turning from multiplication into division or from division back into multiplication. Let's look at another example here. 6y to the negative third times 2y to the fourth. So if I write that all out in expanded form, we've got 6 times y to the negative third times 2 times, oops, that looks like a subtraction sign, times y to the fourth. All right, since multiplication, the order doesn't matter, the 6 times 2 part makes 12. That's pretty easy to get. But now we have y to the negative third times y to the positive 4. So how do I deal with that? Well, we know when we have the same base, our product property says add the exponents. So that turns into y to the negative 3 plus 4. Well, that's just 12 times y. Negative 3 plus 4 is 1. So it's 12 times y to the first power, or just 12y. So there you go. Who knew? All this simplifies just into 12y. 12y is so much easier to work with. This is not very easy to work with. That's complicated. So being able to simplify and being able to take a big pile of algebraic junk and expressions and be able to condense it, make it simpler, and work with it, that's just a great skill to develop, especially as we start moving into more and more complicated algebra. All right, we have one more example to deal with. And again, I wanted to do an example using the power of a power property. Notice we've been kind of reviewing all our properties. Here's the negative exponent. This one reviewed working with fractions and exponents. This one reviewed the product property. This one's going to tie negative numbers with the power of a power property. So normally we know power of a power. You take the exponent and you multiply them together. Well, in this case, one number is just negative, so 6 squared all to the negative third power is going to turn into 6. I have negative 3 groups of 2, so it's sort of like 2 times negative 3. That's the pattern as we multiply the two exponents. Well, 6 to the 2 times negative 3 is just 6 to the negative 6 power. To simplify it, though, I need to have no negative exponents, so I'm going to rewrite that then as 1. And instead of multiplying 6 negative 6, it's going to be divided by 6 to the positive 6. So that negative sign implies division. And then for my final step, let's calculate what is 6 to the 6th power. I can do that. It is 46,656. All right, so there are 4 examples of using negative exponents but complying them with the product property, power of power property, and all these other different properties that we have. And again, I hope as we're doing these, it's making sense about why we can do these and how we can rearrange exponents and simplify them down the way we are.